In example 9, we have a couple problems that are very similar to the ones in example 8, except this time we have two terms up here in each one of the exponents in each one of the problems as well. So we're going to go ahead and try to solve these, and then we'll provide our answer in terms of common logarithms, and then also use a calculator to find the approximate value. So we're going to do the same thing that we did previously, and that's just going to be to take the logarithm of each side. If we do that, that allows us to move the exponent out to the front. You have to remember to use parentheses here. And then this is going to be x minus 2 log 5. So the only difference between these and the previous examples is that prior to example 9 here, you just had to do this one distribution on like the left side, and now we just have to do it on the right side too. And then all we're going to do is we're going to rearrange the terms so that we get the terms with the x's on one side and all the other terms on the other. So if we do that, we could subtract x log 5 from each side. So this would be x log 2 minus x log 5. And then we want this negative log 2 to be next to this negative 2 log 5 here, so we could add log 2 to each side. Factoring out an x, we've got log 2 minus log 5, and that's equal to log 2 minus 2 log 5. We would divide each side by log 2 minus log 5 and get x to be, oops, forgot a 2 there, log 2 minus 2 log 5 all over log 2 minus log 5. You could write this down as your final answer. If you wanted to clean it up a little bit, you could clean this up, and you would have to move this 2 up here to the exponent position, so that would be 25. And then what you could also do is combine these then, and that's going to be 2 over 25. So if you just use your condensing rules here on the top, you'll get this value. And then in the denominator, if you use your condensing rules, you'll get 2 divided by 5. So this could be your exact answer as well if you wanted to. To find our approximate answer, just go to our handy dandy calculator, and we will type in the log of 2 divided by 25, or if you prefer, you can go right back to this this other equation up here, or expression on the right hand side, and then we're going to do log of 2 divided by 5 as well. And that should give us about 2.75, although there's a 6 on the end there, so we'll take that 5 and round it up to a 6. So our approximate value here is going to be 2.76. And again, if you wanted to check this, you can just go right back here and type that 2.76, or better yet, use your calculator's more precise answer, and plug this in, and then see if the left and the right hand side is equal. We're going to do the exact same thing for, so here's your answers, both exact and then the approximate, and then on the right hand side we're going to do exactly the same thing. Try to do that on a different marker here so our work doesn't run together. And we're just going to take the logarithm of each side, then we'll take those exponents, move them out, always remember to use parentheses. That's the most common student mistake with these. We'll do the distributive property. X log 6 plus 2 log 6 equals another distributive property, x log 14 minus 3 log 14. We'll factor out, before we factor things out, we got to move them together, so at least get the terms with the x's together, so let's do that. Let's subtract x log 14 first. and we'll subtract 2 log 6 from each side. Then what we need to do is factor out an x. We'll have log 6 minus log 14. And then if we wanted to do some exponent work here, we could, if we wanted to, take this negative 2, put that up here by the 6. So this would be log of 1 over 36. 6 to the negative 2 power, if we move that up there, is 1 over 36. And this 3 can move up. And if we do that, then, well, we'll make the negative 3 come up to the top there. And I gotta type that into the calculator here, what 14 to the negative 3 is. And that's quite a small number, so we'll do 14 to the 3rd power. That's a little bit better. We'll put that in the denominator. So this is going to be log of 1 over 2744. And then this one, we could now go ahead and we're going to divide each side by log 6 minus log 14, which is just log of 6 over 14, or 3 over 7. So x is going to be whatever this is combined. We need to multiply those together. So I'll multiply that by 36. That'll be our new denominator. So we've got log of 1 over 98,784, and that's all in that argument position. And then the bottom here, we're going to have 6 divided by 14, or 3 over 7. And that's all, again, that's just changing all of this into just one log on the top and one log on the bottom. But if you didn't want to do that, that'd be okay as well. Your answer would be negative 2 log 6 minus 3 log 14 over log 6 minus log 14, and that's fine. So there's our exact. Let's work on our approximate here. So we'll do log of 1 divided by 98784, and we'll divide that by log of 3 divided by 7. And that should give us our final results. We've got 13.57. We'll keep the 7. And there you are, the last example from this learning target.